All right, so we're going to continue our vaccination story with a little more information. And a really important topic we need to discuss is called herd or community immunity. I think the herd immunity is an older term, and community immunity is a newer term that's being used. I guess people don't like being described as herds. But anyway, what this concept is, and this is something that people don't generally realize about vaccinations. When you choose not to get yourself vaccinated or to have your children vaccinated, it doesn't just impact those individuals. It can actually have an impact within the entire community in which you live, and that's because of this concept of herd or community immunity. And what this means is not all members of a community or a population have to be immunized to limit the spread of an infectious disease. Generally, if you kind of hit around the 90% level, it's going to severely limit the ability of that infectious disease to be transmitted within a community. And so there's a graphic over here that illustrates this. All right, so our blue people on here are healthy, they're not sick, and they're not immunized. All right, and then the yellow people are immunized and healthy. The red people are not immunized, they're sick, and they're contagious. So your yellow people are your vaccinated ones. So look at this first scenario. So we got a bunch of blue people, a couple of red sick people are now in the community because they've acquired some infectious disease. And what's going to happen in this community? So nobody's immunized. This could be an infectious disease for which we don't have a vaccine, and it's going to spread throughout the community. Lots and lots of people are going to get sick if this is a contagious type of infectious disease. All right, now look at this second scenario down here. What happens when you just have a few people within a community who are vaccinated against an infectious disease, and a couple of people wind up coming into the community who are sick? You're still going to have a large amount of people within the community who become ill. But look down here. So this is what goes on when you have good herd immunity, good community immunity in effect. So we've got a population of people down here, and most of the population is immunized, not everybody. We've got 4 blue people here. 2 red people are now sick in the community, and so we have the ability for this infectious disease, this contagious organism, to spread throughout the community. But because so many people in that population are vaccinated, it makes it very difficult for this infectious disease to move from host to host to host. It helps break the chain of transmission. So when this red person, or let's say these yellow people around that red person get exposed, they've been vaccinated. They're not going to get sick. And so it's going to be difficult for this blue person, unless that blue person has direct contact with one of those 2 red people, to actually pick up that organism. So that's this concept of herd or community immunity. When you have the majority of a population, generally around 90% in a community, who have received a vaccine, it helps protect everybody in the community, because it makes it more difficult for a contagious organism to find those people who are unvaccinated and unprotected, because you're breaking that chain of transmission from person to person to person. Something else that's interesting, those attendants, remember with vaccines we said that there are some types that you get where you are receiving a live or replication competent microorganism, but it's attenuated, so it's not capable of making people sick. When you get one of those vaccines, you actually shed that organism. You can transmit that organism to other people. So that's an advantage of those types of vaccines, because then the unvaccinated are actually getting vaccinated. They're receiving that organism when they have contact with you, and they don't even realize it. So that's thought to be one of the benefits of those types of vaccinations as well. So this community immunity, like we see down here, this is something that's jeopardized by the current anti-vaccination movements. So in fact, there are some communities now, especially on the West Coast, where you have communities that look like this. So you've got places where we're maybe even getting to the point where the majority are not vaccinated against some really severe infectious diseases. And so that's why we're having the reemergence of things like measles, that have been essentially gone in the United States for a long period of time, because we have a very safe and effective vaccine for it. But now, people aren't getting their kids vaccinated, and because of these unfounded fears against vaccination. and that's jeopardizing the health of not only their children but other people in the community as well. Another thing you have to think about is like a lot of these childhood illnesses we get vaccinated against. Yes, you develop memory to those organisms, but memory doesn't last forever. You know, maybe you get re-exposed to these things, and that helps boost your memory and your immunity. But you know, what if that doesn't happen? You know, as you get older, your memory may be breaking down, or let's say you're immunocompromised, and so you don't have the ability to generate antibodies and T cells and so forth effectively if you do wind up getting exposed to some type of pathogen. So that's of a huge concern when you don't get yourself or your children vaccinated and our community immunity breaks down. It puts other innocent people at risk. These people who are immunocompromised, or maybe they're older, and you know, the memory of their vaccines is not working for them as well. They really need the protection of that community immunity. You need to keep those, keep that chain of transmission of these infectious microbes broken so that they don't become sick. So in the full PowerPoint here, there are a couple of articles. There's one from the NIH, National Institutes of Health, on community immunity, and there's a Time article from Time magazine. Those would both be really good things to read for some more information on this topic. And your textbook talks about this quite a bit as well. It's a huge, huge, huge issue. This is a graphic I pulled off of the Centers for Disease Control website in 2014, and it shows the recommended immunizations in the United States for children from birth through 6 years old. So you guys can kind of take a look at that. You may have seen something like this before if you have children, so you can see what they are recommending. And you know, some things you have to wait until the immune system of the child develops a little bit more. And this is some of these things are Hep B for hepatitis B virus. RV is rotavirus, which can cause a severe intestinal illness with nasty diarrhea. The DTaP, we talked about that. That's the diphtheria toxoid, tetanus toxoid, and then your pertussis vaccine all combined together. HIB is HIB, not HIV. HIB is for Haemophilus influenzae type B, which can cause meningitis in children, something very serious to think about. PCV pneumococcal vaccine, that can cause meningitis in children. IPV is the injected poliovirus vaccine. That's what that stands for. Now, probably everybody who's listening to this video clip, when you got your poliovirus vaccine as a kid, it was the oral poliovirus vaccine, the OPV, that they squirted in your mouth and you swallowed it. And that was an attenuated poliovirus. Poliovirus actually has host cells along the intestinal lining, so it will replicate there. In a minority of cases, though, it spreads to the spinal cord, and it kills motor neurons that send signals to your skeletal muscles and tell them to contract. So that's how poliovirus causes paralysis. That's how it paralyzes. It kills motor neurons in the spinal cord that communicate with those skeletal muscle fibers. So that oral poliovirus vaccine is a great vaccine. It worked really, really, really well. And it's attenuated, so it does not spread to the spinal cord in a normal, healthy person and cause paralytic poliovirus infection. But it stimulates great immunity. It'll still replicate in your intestinal tract for a while and stimulate great immunity, and then it winds up going away. So why did they stop using it? Well, there are risks associated. And again, we have to make sure that the benefits outweigh the risk. I keep flip-flopping those terms in these lectures. And with the oral poliovirus vaccine, what was happening was, in like a few cases out of so many millions, it's a replication competent virus. Remember how we talked about, it's an RNA virus, by the way. Poliovirus is an RNA virus. And we talked about how many of those viruses mutate pretty quickly. And so in a certain very small subset of people who got the oral poliovirus vaccine, the attenuated polio would mutate and become the virulent polio again, and they developed the paralytic poliovirus disease. So when we got to the point in the United States where poliovirus was no longer a problem, the benefit of continuing that oral poliovirus vaccine no longer outweighed the risks. poliovirus is eliminated in the United States. Humans are its only host, and there are no more cases of polio in the United States. Now we want to make sure that continues to be the case. So now they have switched and they give kids the injected poliovirus vaccine in a muscle, and there you're getting the whole poliovirus, but it's inactivated. It doesn't replicate. And so you still generate an immune response to that. It's just not quite as high quality as what you get with the oral poliovirus vaccine, but you no longer have those risks, those little minor risks that were associated with the oral poliovirus vaccine. The whole polio story is very interesting. The World Health Organization is trying very diligently to get the entire population of the planet, all the kids across the entire globe, vaccinated for poliovirus, and they've been trying that for decades, and they still have not been successful. There still are pockets of poliovirus infection in children around the world. There's also some concern that terrorists could bring poliovirus back if we stop vaccination eventually. So that's why we're going to continue to give this injected poliovirus vaccine here in this country. Some other ones, influenza vaccines are recommended for kids once they hit about 6 months old. Varicella for chickenpox. It's another name for varicella zoster, the chickenpox virus. MMR, mumps, measles, rubella, the German measles, hepatitis A. MMR, that's a grouping of 3 different attenuated viruses, by the way, that you're getting all in one vaccination. They just don't tell you that that's a live viral vaccination. This is another table from the CDC, which is a pretty good one, which shows you, here are all these very serious childhood infectious diseases, or even adult infectious diseases, that we have good, safe vaccines for. And so here it's summarizing the vaccine that will deliver these antigens to you and protect you if you actually get exposed to the real thing. And it's a pretty good chart to look over, how are these diseases spread, what are the symptoms and the complications. So over here, this is what you're avoiding if you actually get these vaccinations and stick to the schedule of vaccinations as well. All right, so that was just kind of we've finished up our overview of vaccines, a really, really important topic for people going into healthcare. If you have any contributions to make to those discussions, please feel free to post those over on the discussion board. With Chapter 14 now we finished covering the basics of the immune system, and now we're going to talk about some immune system disorders. We won't be able to cover everything in Chapter 4 due to time constraints, but we will hit some of the major highlights from that chapter. Some pretty interesting things that go on when things go wrong with the immune system, and some things I think you'll find pretty interesting, like how allergies actually happen. I imagine most of us have at least one type of allergy that we deal with at some point during the year. So we'll talk about how those develop as well as we begin Chapter 14.